find rectangle with corners as 1. Okay, we're given a n by n binary matrix consisting of zeros and ones. Find if there exists a rectangle or square within the matrix whose all four corners are 1. Okay, so we are given a 4 by 5 matrix. We have 1 0 0 1 0 0 0 1 0 1 0 0 0 1 0 1 0 1 0 1, and these ones given in red are the four corners of this rectangle. So 1 0 0 1 0, so 1 0 0 1 0. I'm just trying the first example. 0 0 1 0 1 0 0 1 0 1, then 0 0 0 1 0 0 0 0 1 0, and 1 0 1 0 1 1 0 1 0 1. So like if we consider this one, okay, this is at one of the corner, and onto this right we are having this one. Okay, now we need to check whether there is any one along this row. Along this row we are having a 1 here. Okay, now we need supposed to have a 1 which is along this column but and on this row, but here we are having a 0, so that means it's not possible. So with this one as a corner, we will not be able to find anything. Now we move right. Okay, we are just traversing through the matrix, and now we see this one. Okay, if we see this one, we need to check onto the right. We also need to check onto the bottom. Now onto the check of the right, we are having a 0, and after that it's out of bound. So making this one as one of the corner, still we will not be able to find. Now we reach here, we look for only ones. In this case, like we need ones in the four corners, so we'll be looking for 1. So we see 1 here. Okay, we see 1 here. Now we will be looking to this direction, and we will be looking to this direction. Okay, so if we go here in this direction, like we see a 1. Okay, and let us keep it as a corner. And if we move downward, here also we are seeing a 1, so this is also a corner. So this is one corner, this one corner, this one corner. Now the next one is like we need to go through this column and find a 1 such that suppose this is like we can say the index here is I1 J1. This index is I1 J1, and this will be I1 say some J2. Don't care about the correct indexing. Say some I1 J1 and some I1 J2, and the other one has to be on the same column J1, but it will be on some other column, say I2, and the other one have to be on the same row I2 and on the same column J2. So what we will be doing here means we will be just trying to find 1, and we will be just going downward in search of another 1, and we will be going rightward in search of another 1, and if we see those ones, we will just again go and we'll be just checking like we are able to find this one. We are able to find this one, like we can say that we find it, otherwise we can say we do not find it. Now for the second, in the second, like there is no ones. If we have only zeros, there is no need to check, we can directly return a false. So here according to my algorithm, like we are traversing like a big of n square at the first time, and then we are again going to going row wise and column wise. So the time complexity will be on the range of big of n square m square, or we can say big of n raised to 4 in the worst case. So I think that will work here by considering the constraints. Yeah, so let's have the row which is equal to matrix dot length, okay, int col is equal to matrix of 0 dot length. We got the row and column of the given matrix. Now we can just start traversing. So for int I is equal to 0, I is less than row I plus plus, the normal traversing here. For int j is equal to 0, j less than col j plus plus. Okay, now we are just searching for ones in this matrix, and if we have any cases like this, only zeros, then we will not be getting inside the condition that we are putting inside the for loop. We will be coming out after completely traversing through the array, and we will be just returning false. Okay, so if we were able to find, we will be returning true inside that loop. Otherwise, if we exit the loop, that means we were not able to find the four corners with ones, so we will be returning false. So we are looking for matrix of ij is equal to 1. So if matrix of ij is equal to 1, so like in this case, let me clear this. So let me say 1 0 1 0 0 0 1 0 1, just taking only that part. So let's say I am at this position, and this is a matrix of ij, and this is equal to 1. Now what I am doing means, I will be just keeping this column fixed, like I will be just checking whether this is equal to 1. No, whether this is equal to 1. Yes, this is equal to 1. Now after that, by keeping the row fixed, okay, the row fixed, I will be just moving to the right, and we'll be seeing, and at the position, if I see, so let's say this is I, this is j, okay, or say this is k, just say this is the ith row, this is the kth row, and if we analyze about the column, say this is C column C, and this must be the same. Like we need to have, say, matrix of I C equal to 1 and matrix of K C equal to 1 in order to say that we are having a rectangle or square. Okay, so that's the condition that we are looking. So if we see a 1, now we are going down. So for int, let's say k is equal to whatever be the row from there, I plus 1, k less than row, k plus plus, and if I see a 1 there, if matrix of k j is equal to 1, now I am moving row column wise, like keeping one row, the row fixed, I am moving column wise. So if int say L is equal to what is the column, it will be j, so j plus 1, and L less than col L plus plus. Now we need to make sure about this condition. Okay, so that will be if matrix of I L is equal to 1 and matrix of K L equal to 1, then we can return true. Otherwise we keep on searching inside this in this array or in this matrix, in like for possibly finding about the four corners. So yeah, like I mentioned, that the time complexity will be big of n square m square, and the worst case, if we are having an n by n matrix, then it will be big of n raised to 4 time complexity, as we are having, yeah, as we see here. We are not making use of any extra space, so the space complexity will still be big of 1, but we'll be having a power for complexity, and it will be fine considering this constraint. Let's check. Okay, yeah, it is fine. Okay, so yeah, that's the problem. We can just do the very basic check inside the matrix in order to find the four corners, and this is the main thing. Like, otherwise we again need to make one more loop and just check, but this is the condition that we need to find. Like, if we find that one at the particular column, then the row, the previous row where we find, and the new row where we find the one, the same row in the new column we also need to find a 1. So like this one, so we see a 1 here, we see a 1 here, and on the same row we need to have another 1 in a new column. This is the new column, so that column must be the same. Like, we should like, if this is 0 and we are having a 1 here, this is not the case. We cannot have a rectangle in this shape. We need to have those in the same column, on the same row, the same column, on the same row. Yeah, so that's it.